Yeah, good afternoon. Good afternoon.
Afternoon, sir.
Good afternoon. I think everyone had a lunch, right?
Yes, sir.
Okay, we'll start the lesson now. In our last class, we have started the revision class of a module one. Now, again, we'll start with that particular module, and later on, we'll discuss what are the possible MCQ questions it can be there out of that particular module one, and next we'll go to the module two also in this particular record. Now I'll start with the PPT. I'll share. Then afterwards, I'll move with the slides. Uh, yeah. Now I'll start with the sharing option. Yeah. Share window. We'll go here. We'll share this only. Right. Yes. Shared. Now I'll go to this chapter one. In a chapter one, as we had discussed last time. Yeah. Now, coming to this, we have discussed about different applications of the different applications of the computer networks. First, we started with the definition, and I have told you that what are the possible questions which will be comes in this particular applications and how to write answer in exam, what type of question will be there. And as usual, I have told us how a URL request, one URL request will be there within a 7 messages to connect to the server. So how it will be done. Then we gone within a requirements. For a requirements, three actives are very important in a network designing. There is an application programmer, network designer, and network provider. We have discussed this also, and we have gone with the connectivity. That is how a one system with another system the connectivity will be done, and what are the different terminologies we are going to use and why that terminologies is needed. We have discussed all these terminologies and have explained you what is a circuit switch and network, and what is packet switch and network, and how interconnection of a networks will be done, and how a circuit switch can be established. Coming to the next thing, we had discussed the this one also means the multiplexing concept also. Out of this, again, the questions will be there. So how the multiplexing will be done? Assume that there are several users are there, and several resources are there, or senders are there, and several receivers are there which are connected to the same line. So where combining of the packets from several senders to be done, and receive demultiplexing, and there at the receiver end it should be bifurcated and given to the perfect receiver according to the address. So how this thing will become, we'll call this concept as a multiplexing and a demultiplexing. The combining process will call it as a multiplexing, and later on demultiplexing. As I told you, that time division multiplexing with a synchronous concept, that is synchronous time division multiplexing. What I told you that each sender will be assigned one particular slot of a time. At that particular time, the sender used to send a packet, then that schedule or queue will be rescheduled. That is S1, S2, S3, again S1, S2, S3. Now, what is the disadvantage of this particular concept? We had discussed that assume that S1 and S2 don't want to send a packet. The allotted slot time will be as if there for that particular things, and no packets will be sent in that time. Assume at the same time S3 wants to send a packet, then S3 has to wait until the S1 and S2 turn of a slot of time will be completed. So then there is a waste of time as well as, and there will be a delay, and the waiting time of S3 will be increased. So this is a disadvantage as we had discussed. Coming to the next concept, that is a frequency division multiplexing. There we have discussed that is an analog based concept where a data will be stored in a wave format, that's in a frequency, and this will be accelerated, so that will call it as a frequency. Now how this particular frequency means, different frequencies will be added to a single frequency, and a signal will be sent, and there at the receiver side that signal will be received, and later on it will be divided or chopped into a different frequencies. That we have taken an example of an DTH concept, that is sun direct dish TV, how it will works. So I have explained you. In a computers, we are now using a multiplexing concept, that is a statistical multiplex concept. That is, we are using time division multiplexing only here, but here on demand basis, the request will be accepted. What is on demand basis? The accept will means there will be a accept. That is, assume that S1 wants to send a packet, then the packet will be taken from that particular S1, and it will be forwarded. So what is the problem here? Assume that same time two senders will send a packet. Means two senders want to send a packet. They will demand, means they will demand a flow. Then what it will be do? So first one will be taken. The next one will be in a queue. Then what types of queues it should be maintained, the router or the switch which will be there. So what type of queues it should maintain in the things. So there will be a different types of queues, that is a FIFO will be there, round robin method will be there, and priority based. For some packets, priority based queues is important to improve the quality of service. So based on this, the conjunction will be there. Means how much packets are coming and how much we are storing in a queue. If more than a packets are coming of a queue capacity, then definitely that packets will be dropped. So that stage we'll call it as a conjunction. So then in the last class itself, we have discussed about LAN, MAN, WAN. So LAN is a distance based, it will be types of computers will be divided, where if a maximum 500 meters of capacity is there of local area network, where a maximum of 256 systems you can have in each LAN, and you can use Cat6 cable for connecting this, and you can use a hub to connect this switch hub for connecting this particular systems in a LAN. So MAN is a metropolitan area network where you can consider from 3 to 5 kilometers of a distance. Here we are using analog concept. Coaxial cable you are using to coaxial cable is there, your computer is in a digital system, so there must be a converter between the coaxial cable and your computer, that you need a modem. So that is, modem is the one which will considers the analog signal and it will convert to the digital signal, and vice versa, considers the digital and converts it to the analog signal. So you need a modem there, and as well as whenever you are using a coaxial cable or analog signaling concept, then you need amplifiers also to strengthen up the particular signal whenever the signal moves in a far place. So in this way, these are the components which will be used in a MAN. Coming to next, in a WAN, if you want to connect an internet facility from one country to another country, or one city to another city, then you are going to use a WAN, wide area network. That's a different combinations of LANs, MANs you can take, and you have to connect, where large amount of data will be transferred in a WANs from one city to the another city. So there you need a large amount of data transferring medium. Maybe this is an MCQ question for you. That the maximum large amount of data transferring medium is Cat6 cable, OFC cable, and analog copper wire cable. Like this may be a question. So then you have to tell optical fiber. Optical fiber is a one cable where you can transfer a maximum amount of data from one place to another place using total internal reflection concept in optical fibers. So maximum you can connect to 60 to 70 kilometers. More than that, if you want to connect, you need a repeaters there. So repeater is a one where again it will means that's the one which will collect the optical signal, again strengthen up the optical signal, and it will send. Finally, a media converter is needed to convert an optical signal to the digital signal at both the sender's place as well as the receiver's place. So this is the LAN, WAN, MAN, which we had discussed in a last class. Coming to next, logical channels, application to application communication path or a pipe. So how one host will be communicated with other host through a public internet. You can see here, this is a one host and this is another host where both applications are running. Assume application means here chatting application you can take or any mails you can take. So how this things, the information from one application of a host will be sent to the another application of a host via public internet. So that process communicating over an abstract channel, whatever a channel is there, that we'll call it as a logical channel. That is, a logical channel will be established, a path will be established, pipe will be established from one system to the another system for the communication purpose. So that logical channel will be there as a temporary until the sender will send all the data to the receiver. Once everything is completed and handshake will be there, then the connection will be terminated, as we have discussed in a starting slide with the 4 messages. Coming to the next thing, entire computer network will be based on a client server architecture. This can also be one of the another MCQ question. Two types of communication channels will be there always. One is a request reply channel. That is, the client will request, the server will reply for that particular request. So another one is a message stream channels. What is a message stream channels? The client, whatever it wants, it will put in some message stream channel, and then server will take that information from that particular buffer or a channel. It will read it. Whatever it wants, it will keep again in that particular buffer. That means one common stream of messages or a channel will be there where both client and server will be interacting. There will be two types. One is a queue type and another one is a socket type of programmings will be there, where request and reply will comes in a socket programming which you have did in a lab program. That is how a server socket in that particular thing, how a socket will be there, and what are the different functions you are using. For example, in a server, after binding of all the protocols suite and address, then the server will start listening. That means the server is in online. As one request comes, it will create a new socket, and then whatever is there, it will receive the request from that particular channel, means that socket, and again a reply will be done. Same thing in a client side, that client will first connect to the server address. Later on, it will send once the connection is accepted, later on it will send a request, or it will receive that particular reply. So this is a concept which we had discussed in a lab program. There is another one that is there, the queue format communication, that is called as message stream channels, where queues will be created. That is, for example, I can say one queue will be opened in a write mode and another queue will be opened in a read. For example, I will tell you like this. Listen carefully. A client will be there. So client will have one particular queue or a buffer will be there. So for a client, there will be a write permission, and for a server, only read permission is there. Another queue will be there or a buffer will be there. where the server will have a write permission and this client will have a read permission. That is FIFO1 and FIFO2 both queues will be there, or a stream of channels will be there. Assume, for example, I am telling the client whatever it wants, the request whatever is there, it will writes into that particular channel of Q1, and now server can read from that particular channel. Only read permission is there, so it will read what server it wants. After reading that, the server whatever it wants, it will writes into Q2, but the client will have only read permission from a Q2. So it will read the data from a Q2. Like this, the message stream channels, which is going to work. Coming to the next, reliability. That we have discussed that how a reliability connection should be established from one system to the another system. Then how best the connection should be there. So the network should hide the errors. This is very much important. The errors shouldn't be there. The errors should be hide, or error detection should be done. If errors is there, then retransmission of data should be done. Bits are lost. Assume bit errors 1 to 0 or 0 to 1, vice versa. It will becomes. So that we'll call it as a bit errors. Burst errors is there. Several consecutive errors will be there. That means assume here more than one bit, that is two or more than that bits. If error occurs at a time, means that we'll call it as a burst errors. So bit errors means only one bit will be changed at a time. That is, one will become a zero, zero will become a one. MCQ question can be asked there also. Then packets are lost. So if packets drops out from a queue of a routers and all, then we'll call that as a congestion. Links and node failures. That is, whenever a particular devices will fire, or in between path or a link, the medium will be filed. So messages are delayed, means sending a message from one place to another place, if it delays, maximum time it will take, then automatically we'll tell it's not a reliable network. Messages are delivered out of order. What do you mean by out of order? For example, for this particular destination, the message has to send, it will goes to other person, or it will goes to the another person, where another person or another device will discard that particular messages. Third parties will be there. That's we'll call it as a eavesdrop. That is, while both two are communicating, two hosts in between, some other person can connect, and he can collect that information, or he can theft that particular information. So that is also will be there, which will cause a reliability danger, which will reliability will not be there. To solve all, if you solve all these terms, whatever is there, then automatically reliability will be maintained in a network. Now coming to the network architecture. So network architecture is always built within a layered concept that you first keep in your mind. What is a layered concept? What is a layered concept? I will tell you like this. Assume that one system is connected with another system. System knows only zeros and ones. But as a user, I know only English and some applications I know. That means from an application level to sending a zeros and ones, collecting from other system that zeros and ones, converting again to the readable English to the application, we need some layers. So that layers we will call it as a layered architecture. Each layer will do its own function, will have its own function, but one layer output will become an input to the other layer, or one layer is dependent on a other layer for a service. So this is called as a layered system. Now you can see in this particular figure, first application programs means up from application, process to process channels is there, that is establishment of the connection from one device to the another device, either all the information sequence in a sequence, either it moved or not. Then host to host connectivity, that is either the blocks of information whatever is going in a correct pathway, whether it's reaching perfectly the destination or not. Host to host connectivity is there or not, means one to one connectivity is there in between all the nodes, so that will be checked. Again, coming to the hardware. So in a network adapter, how the data will be converted to the zeros and ones, how that zeros and ones will be flowed in a medium. So whether that medium is supporting to flow that zeros and ones. So that things will be there in this particular layer. So here the layered concept is very much layered system with alternative abstractions available at a given layer. Now, what do you mean by this? Application programs, you can see here. Here, application programs is there. There is a two types of connection establishment, as I told you in a last class. That is request and replay, socket programming, message stream channels. It will maintain a buffer of queues. But host-to-host connectivity will be same. What do you mean by this host-to-host connectivity? So whatever a connection is should establish in between nodes, that will be same. What is this here? This is source and receiver, or a client and a server. So here end-to-end process, that is source to destination. This layer will place. But here in between nodes, that is source to first node to second node to third node to fourth node, until the destination store. Then hardware, from how one system to another system, the zeros and ones will be exchanged. Coming to the next protocols. There is a many MCQ questions can be asked on this particular protocols also. What do you mean by this? I will tell you like this. A protocol is a one that is a rules and regulations between two devices to communicate. In general, I am telling you, there is a rules and regulations to communicate between two devices. So what do you mean by this? Whenever information should be exchanged from one system to another system, the system should follow some protocols, some rules and regulations. As I given an example of hierarchical, both the ways we have to communicate always. For example, assume that if I want to communicate with other college person, if I want to communicate with other college person, or any other college person of my friend and all, the protocol will be different. If I want to communicate with my authority, higher authorities, the protocol will be different. So if I am communicating with my friend, then the protocol or the way of speaking will be different. I am the person, single person, but I am maintaining a protocol while speaking with different persons. So like that, each protocol object has a two different interfaces. What is that? Service interface will be there and peer-to-peer interface will be there. What is service interface? Operations on this protocol. That is how this protocol is helping the above layer and below layer. How this protocol is supporting the above layer, how it is communicating with the above layer and a below layer. Means how it is providing a service to the above layer and a below layer. So that is called as a service interface within a system. Within a system, if one n layer is providing a service to n plus one layer and n minus one layer with some protocol, that operation, that service, we'll call it as one work of a protocol. Then the peer-to-peer interface. What do you mean by this peer-to-peer interface? The n layer in a host 1, nth layer in a host 2 will have the same protocol or same functionalities will be there, where a communication or messages will be exchanged from one person to the another person. For this, the best example is the language translator at both the sides. That I have told you this particular example, that a only French known person wants to communicate with a only Japanese language known person. So how these persons they will communicate? Here, whatever will be there, the person who knows the French and English, that particular person will be there in a sender side. He will collect the French language and he converts that French language to the English language and he will send further. So it will be passed to the next system. Assume there here one person will be there who knows English and Japanese. So whatever English language it's coming here will be collected from this person and he will convert that to the Japanese. Why? Because he knows the Japanese and English. Now English is there here. So you will correct that, and in this way the French person will communicate with a Japanese language with the help of the mediators. Now assume this, the translators. If you consider a translators as an nth layer, this translator is assume the nth protocol is there here. This protocol should know the French, how French will be there, French grammar, everything. So you should know that particular thing. Then it's converting to the English language. It should know the English grammar, everything, English, everything. So converting is a one work. It will be done. Here, this side, the same person will do the same work. He should know the Japanese language, Japanese conversion, everything. He should know the English grammar, everything. So conversion is same for these two persons. So that's why here peer-to-peer interface, we will call it as these two as a peer-to-peer interface. This is called as service interface. Then the term protocol is overloaded specification of a peer-to-peer interface module that implements the interface. So that also is a one particular concept. Now in detail you see this particular figure where you can understand this. High level object is there, protocol is there. This is called as a service interface. That is within a host's one system, how this protocol is giving a service to the higher protocol. So that is service interface. Now observe the peer-to-peer interface. Assume this is a translator here. This protocol is a translator. Now French, high level object. So French, giving French, taking a French language, converting to English, taking an English, converting to the French language. This is service interface. Now what he will do, he will consider English, translates to Japanese, considers Japanese, translates to English. So this is service interface in a host. Now both are doing the same work, the translation work. So that how they will do, I did in this way the translation and all. So this English will have these many terms. So all these things will be quoted here. So that is called as a peer-to-peer communication. So this is a very important concept one must know in a protocols. Protocol specification, pros, pseudocode, state, transmission diagram, everything will be there. This is a one which will authenticate the protocols, means the international organization, IETF. There may be a MCQ question here, which international organization will authenticate the protocols for an internet, assume. And there will be IEEE, Elsevier, something like that they will give. OSI and IETF. Then you have to click IETF. Why? Because Internet Engineering Task Force is an international organization which will authenticate all the internet related protocols. So that point you must know here. Now this is a protocol graph, how a protocol communication should be done. Observe carefully here, the nodes are protocols and links that depends on a relations. Here nodes whatever. File application is one protocol, digital library application, video application. Observe carefully here. The file application and digital application, whatever is there, will works with request reply protocol. So video applications, whatever will be there, video and audio applications will work with message streaming protocols. That you must know. So these two concepts will be there here. So if this function is going on, then request and reply concept will work. Then host to host communication, host to host protocol will be there here. So that host to host protocol will be connected with another host. So like this, in between there may be n number of nodes. This cloud will represent the n number of nodes. Now observe the next particular figure here. The application program will send a data. Are you seeing here? Data. Now what RPP will do, RPP will have its own label or header, will be encapsulated, will be added to this particular data. It will tell I did so and so function or so and so work here. I am sending this particular entire data, means it will be packed, encapsulated here. This is an encapsulation. With this the data will be there. The data will be put in a cover, and that particular seal will be applied. Applying that particular seal and covered data with RRP. What do you mean by that? Request reply. Here, which is the source, which is the destination, what is the identification of this particular data, what is the unique number, all details will be put, which can be known only to this RRP. Why? Because this RRP function and this RRP function is the same. Assume, for example, I'll tell you the translator here. How we did a translator, everything, all details about this translating information, everything, it will be stored here. Okay, and it will be covered and it will be sent to the HPP. HPP never matters anything. What is this host to host communication? Host to host communication thinks entire this as a data. It never bothers what is there in a RPP. Keep in your mind. So now entire this thing will become a data for a host to host protocol, and it will have its own header after checking all zeros and ones, everything is correct in sequence, everything. RRP data is now adding data. It doesn't knows that. It's a encapsulated, this is means covered. Then again the HTTP will put that in another cover, both. Now single cover again it is. Now that is HTTP seal will be applied. That is this particular frame is so and so frame, sequence number is so and so. That will be with so and so checking error code checking details. Everything will be there. Now that will be sent to the host system. Now what host system in that HPP layer, what it will do, first it will open HPP header and it will see a sequence number checking everything. Here no RPP, no data, it doesn't know that. RPP and data are both to HPP protocol. So after doing this, yes, everything is correct, the sent zeros and ones is correct, frame is correct, then automatically it will be sent to the RPP. Then what RPP here it will do? Now this wrapper has removed HPP wrapper and it will be sent. Now RPP, we will read this particular information, whatever this RPP is given. That is, this is so and so sequence number packet and so details is there. So and so source, so and so header means destination, address, everything will be there. Everything is correct. Yes, everything is correct. Then it will take out its cover and the pure data will be sent to the application, where whatever the application here it's going on, the same data will be represented there. In this way, the encapsulation will work. The MCQ questions will be there on an encapsulation, giving you the encapsulation data format. Means how it can ask you that the HPP, for example, HPP RRP data, whatever is it, this type of a packet can be read by either HPP protocol or RPP protocol or application protocol. Only HPP protocol can read this type, all three. First it has to remove. Then RPP and data can be read by RP. So that you have to keep in your minds. Now OSI architecture. Here many MCQ questions will come over here. How many layers are there in a OSI architecture? First question, everyone will miss there. Almost all, either in overconfidence, either in some unknown things and all, they will give you maybe like this 5, 6, 7, 8, 9. Assume, for example, if you doesn't click 7, then you doesn't know even a computer architecture at loss, means at least. So OSI reference model, always 7 layers will be there. That you have to keep in your mind always. That will be the first question. So after that particular question, what will be the other questions? Based on a functioning of each layer, the questions may arise. As I already explained you, what is a physical layer, what is a data link layer, what is a network layer, transport layer, session, presentation layer, and an application layer. So physical layer always deals with zeros and ones and which medium it has been connected. Data link layer collects the zeros and ones, converts that to a frame, and it will checks for a flow control, and as well as the error detection process will also be done here in a data link layer for a host to host communication, not the source to destination. Here the host to host communication, for that the data link layer is going to work. Then the network layer. What a network layer will do, here frames will be converted to the packets. The other work of a network layer is establishing a route from the source to the destination via other different nodes through the IP addresses or on a network addresses. So that is a one work which will be done. Again, the congestion control will also be done in a network layer, whether the packets are moving correctly to the destination or not. Maintaining the links, maintaining the route, everything will be done in this particular network layer. Giving an addresses to each and every device will be done in this network layer. Coming to the transport layer, that is where end-to-end process. Assume from application, it has been given some message, and that message will be converted to the segments, and each means segments will have some 100 packets is there overall a message. So what is this? Here network will deals only with the packets. Whether packet is coming, that packet is moved or not correctly in a route. But here transport layer should have a look from 1 to 100 packets. Either all 1 to 100 packets moved correctly to the destination, either all the packets gone in a sequence. If it is not gone in a sequence, retransmission of the packets must be done. So when it should be done a retransmission, after reaching all the 100 packets in a sequence, then how to cut the connection or how to establish the connection. That means end to end process from 1 to 100, all packets are moved to the destination, all 1 to 100 are in a sequence. So that work will be done here. The session layer, whatever is there, for every end-to-end process, a name must be given or a identification must be given, and a time slot should be fixed for that. That will be done within a session layer. That is, a session layer will give a name for each and every end-to-end process. That means all 100 packets belong to this particular X group or Y group, M group, Z group. That is a name. There's a session name. And within this particular maximum time, all this particular packet should go. And if it is not going, something is happening. So again, retransmission of all packets should be done now. So that's a session. Whether that entire session is maintained correctly or not will be done by this session protocol. Coming to next presentation protocol. What is this presentation protocol? As I told you that there in a world for internet, there will be different systems and different operating systems will be there, where everyone will keep on using an internet. That means many operating systems, heterogeneous operating systems and heterogeneous architecture of systems should be capable to transfer the information. That is, whatever application is data is there, it will be converted into network code or network unique code, and that data will be transferred for each and the network unique code will be same for all the architectures or for all the operating systems whenever it's moving with other different layers. When it comes to the presentation layer, based on what operating system it is using and what type of an application it is using, the presentation will be done. Means the network code will be converted to that type of an information. So that work will be done with this presentation layer. It will present the data or a network encoded data in the form of the readable application data. Finally, the application protocol or application layer, it will present the information, overall information of a sender to the receiver. So this will be done, or it will collect the information from a sender, it will send to the receiver. Either ways. So all these 7 layers will work in this particular concept. So this is a OSI layer. So same thing is there here also. You can read it out from that particular thing. The another one is a TCP/IP protocol. Here, TCP/IP protocol, whatever is there, means coming to the TCP/IP protocol, there will be 4 layers. This is very much important. And another one MCU question may be there here, that either OSI layer as came first or TCP/IP architecture came first. Anybody can answer this question? Hello? 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 Hello?
Yes, sir.
Either OSI architecture came first or TCP IP architecture came first. Which one is the old one?
OSI, sir.
Huh?
OSI.
OSI. Oh, any others? Any others? No. TCP IP is the oldest architecture. Before OSI, TCP IP is there. Keep in your minds. If you want, you can Google
Sorry,
it.
sir. Confused.
Okay, so like this MCQ, you will feel like that MCQ is easy, but small. Just if you miss yes or no, type like if you miss, wrong is wrong. So part of marks you don't get. So be careful while answering. Okay. Now TCP/IP is the architecture before the OSI architecture. And now today the entire internet is depending on this TCP/IP architecture. But ARPANET is developed based on OSI. Later on, it is shifted to the TCP/IP, converting the OSI 7 layers to the 4 layers. That is, the application layer, session layer, presentation layer is converted to the application layer, and the data link layer and physical layer is converted to the sub network layer. And again, the network layer is called as IP layer, and your request and reply whatever protocol is called as a TCP, and whatever a message string channels is there, that we call as a user datagram protocol, that is UDP. So in this way, the conversion means from OSI to the TCP/IP it has been done. Later on, TCP/IP has become a well-known protocol suite for a internet. Now you can see here the different level of an application protocols, that is FTP, HTTP. FTP is meant for file transfer protocol, hypertext transfer protocol, and other things. That means FTP is there for audio, video, file transfers. So all this particular thing, whatever is there, means the applications will be connected to TCP and UDP. But you can see here IP means IP is a one which will establish a network layer, route from source to destination. Now this is transport layer, that is end-to-end process will be taken care of this particular two protocols. Now net 1, net 2, net 3 up to net 10 based on different heterogeneous networks, means either the host to host communication or node to node communication will be looked after by this particular network. This is called as a TCP IP architecture. So here also the MCQ questions can be asked. How TCP will be worked? Reliable protocol, TCP or UDP, like that. So the means internet architecture as defined by IETF, it's there. So strict layering concepts and all, you can read it out, not so this one. Then application programming interface, that is your server socket and a client socket. So this is a one basic concept which will works, means which will connect two systems. Either it will connect with socket programming, either it will connect with a queue channel or queue streaming things. So both the ways you can connect. Your seniors lab program is having even that also. FIFO queue method program is there, but for you it has been removed as a third program. For them, the two all both two programs are there. One is the client server socket program, and another one is a queue based client server socket program is there. Means not socket, that is the queue mentioned thing one. So if you want, I will send that program also. You can see once how that program will also work. If you want, I will send you both that server program and the client program, how it will work based on a FIFO queues. Sorry. So this is a application programming interface. What here the things you should know for in a view of an MCQ and all. Socket programming, you should know. You should know what is a socket. It's a unit of instructions which will use it to communicate from one system to another system as a API. So that you must know. So coming to the performance, Here many questions, almost all out of 30, I have given 6 to 7 questions based on performance. Be careful here, and each one of you must follow this particular things. Here, what is a bandwidth? Whatever I have told, formulas, everything, you must take care of that particular thing here. So bandwidth main, you go through this particular formula, and I've given one this one. So you can see here, see at 1 Mbps that 1 microsecond is needed, 2 Mbps data 0.5 microseconds is needed, and previous slide you can see here 1 Mbps, that is 1 into 10 to the power of 6 bits per second. That also you must keep in your mind. On a 2 Mbps link 0.5 microseconds, for 1 Mbps link 1 microsecond. These are maybe MCQ questions will be more on that particular nature. Now observe the formulas here. So I will give some values and I will ask you calculate the delay. So give some values. So then you have to tell. So latency will be calculated on propagation plus transmit plus Q. Propagation will be calculated on distance by speed of the light. Speed of the light, everyone knows, 3 into 10 to the power of 8. This is common. Distance, what is the distance from that node to the another node, which will be given. So assume that, for example, Earth to Moon, assume so many kilometers distance is there. So that distance 3 into 10 to the power of 8. If you take, so then meters, converting to meters. If you take, then automatically you will get a propagation. What is the transmit time? How will you get a transmit time? What is the size of the file it should be transmitted and what bandwidth is there? Assume, for example, bandwidth frequency of a bandwidth, they have given some 5 gigahertz. Okay, and you have to transfer, for example, 5 MB of a file. So first 5 MB you must convert to bits, keep in your mind, and this your bandwidth, whatever they have told, you have to convert into MPPS, means megabits per second, or like that you have to convert into 10 to the power of 6. So after that you must calculate the transmit. That whatever a problem I given in assignment, for this all these three will be useful. Later on you can calculate what time is required to transfer this much of file from Earth to Moon. That question, this is a things which you have used. Many of you asked the doubts right now. So these things must be needed. 1 bit transmission propagation is important. Large bits transmission bandwidth is important. So this also you must know. Coming to the next thing. So delay into bandwidth. How these things will be calculated, whatever a delay, whatever a bandwidth, how delay is related with a bandwidth. So that also, this, on this also some questions is there. You must know the formula for this. Right? So any doubts, RTT, based on RTT also I have asked one doubt, means one MCQ question is there, sorry, one MCQ question is there. What is the RTT? The time required to traverse from source to destination and again back from destination to source, one trip. So that is called as round trip time. What is the throughput? If I ask you, what is the average throughput to transfer 5 MB file from source to destination with so and so bandwidth? If I ask you, so what is the transfer size? What is the transfer time for each particular thing? Means at that particular time, assume exactly now what data has gone, how much data it's gone, note it down. Next, or note it. Out of from 1 hour, within a 1 hour, how much parts of data it has been gone, how many packets it has gone. So how much size it has been transferred, divided by adding up of all size divided by total time. Will give you average throughput. Now transfer time. Sorry, what is the transfer time? That is the RTT, means the sending of a signal data and receiving acknowledgement, plus 1 by bandwidth, half of the bandwidth, into transfer size. So that is called as a total transfer time. Based on this, I have asked one particular question, transfer time. Be careful while calculating this particular things, and these formulas you must know. So this ends the first unit, and tomorrow we'll go with the second unit. So Saturday I'll complete almost all. I'll complete the second unit. I'll give how different MCQ questions will come in that particular thing. So any questions? Just I'll stop now, sharing. Any questions is there? You can ask me now. Any questions is there? Hello? 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 If any questions is there, it's open for you to ask, and 30 MCQ questions will be there in a test. So 1 hour time will be given, I think, to do that. So fourth, I think the online test is there. So yeah, what I've given you instructions, go to Google. So basic fundamental concepts of computer networks, MCQ questions with answers. If you give, plenty of websites will be there where you can see that. Each chapter wise questions is there. That also you can see. You can read it out as a material. If any doubts is there which you can't solve, which you have not understood, you can ask me openly or you can call me anytime. Not a thing. So almost all 1.5 unit is there, I think, in all the chapters, which you can do. Thank you very much. Next class will be there on Saturday uh, at 11:50. Okay. Thank you. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.